And welcome spaced out viewers to the Daily Space Weather. We're going to start out where we left off yesterday with 131 and 94 angstroms from the Solar Dynamics Observatory. Multiple sunspot groups here on the Earth-facing portion of the solar disk. I'm not even going to attempt to conjecture on how many, at least 4 sunspot groups. So I think there are 3 in the southern hemisphere and 1 in the northern hemisphere at the moment. We'll show you more in-depth information on that momentarily. First, the 304 and 171 angstroms. One of the best composite wavelengths in my opinion. Ionized helium and ionized iron there. 304 and 171 angstroms respectively. Here's 1600 and 1700 angstroms. This will show you extreme UV as well as ionized carbon. And we'll zoom in on the northern and southern hemispheres here. First, a look at the magnetic fields. Here's the colorized magnetogram. And you can see at least 3 sunspot groups in the south and at least 1 in the north. There was a moment where there were 6 yesterday. There were 4 in the south and 2 in the north. Here's the northern hemisphere. This sunspot here is doing some activity here. We see the North Pole umbra speeding away from the South Pole umbra. And here's the southern hemisphere. Again, these 2 sunspots over here are the most active, it looks like. And you can see quite a bit of bright white colors there. That's ionized carbon right there on the surface of the closest star. Radio flux is up to 87. And we expect this to rise a little higher here with so many sunspots on the Earth-facing portion of the solar disk. Here's a 1-year chart to put it in context. The radio flux is the black line. The red line is the sunspot number. Next, looking at the Space Weather Enthusiast dashboard, we don't see any warnings from NOAA here. No geoaffectivity expected here, except a minor increase later today and early tomorrow to a KP of 3 from a coronal hole wind stream. Let's look at global seismicity briefly here. Pretty calm levels here as far as earthquake activity goes. There was a weird quake in Baffin Bay. This one here, this 4.4, which came in at just before 7 o'clock Universal Time yesterday. 7 p.m., 1900 hours Universal Time. So we're just going to scroll up the list here. Some rocking in the South Sandwich Islands as well as the Alaskan Peninsula. Looks like the largest quakes were around a 5.3 magnitude. There was one by Guam. There was also one at Papua New Guinea. So pretty calm as far as earthquakes here over the past 24. Kermadec Island saw a deep quake at 5.3. That's about the biggest quake we've seen here over the past 24 hours of 5.3 magnitude. Next, volcanoes. Karimsky is exploding on the Kamchatka Peninsula, producing a 12,000-foot plume of volcanic ash over that desolate region. Subanose-jima, flight level 110. It's an 11,000-foot ash plume over the Ryukyu Islands. Pagan, exploding. 3,000-foot ash plume over the Mariana Islands. Samisa-Pochnoi, one of the Aleutian volcanoes. No information provided there. Don't assume it's not erupting. You're probably not there. It's another very desolate part of the world. Popocatépetl, now back on the list, although no new emissions observed. Fuego exploding. 15,000-foot ash plume over Guatemala from Fuego. Sangay, no volcanic ash observed. Don't assume it's not erupting. Revenador exploding, flight level 160, as it produces a 16,000-foot plume of volcanic ash over Ecuador. Please do not pole vault the caldera. Please do visit our links in the description below the video and support our channel. Sabancaya exploding, flight level 270, as it produces a 27,000-foot plume of volcanic ash over Peru. Let's go back to space. The GOES magnetometers here, the GOES 16 and 17 there. fairly smooth here, and we are expecting a rapid transfer into the North Pole current sheet. Yes, there's a North Pole current sheet speeding our way, folks. And it partially has to do with those active sunspots in the southeast of the closest star. Here is your top view ecliptic plane field plot. And you can see that North Pole current sheet speeded our way. And by tomorrow's daily space weather video, Earth will, in all likelihood, be in this North Pole current sheet. So shown here in green, Earth is about to snap from a South Pole to a North Pole current sheet. Here's the line of sight plot. You can see that blue line coming way down toward the south. Some magnetohydrodynamics here for you in today's daily space weather. Next, the line of sight coronal hole plot, showing you the sun's B field in blue. And you can see a significant North Pole coronal hole up here as well. It's now stretching beyond the equator. So we've finally got a trans-equatorial coronal hole here, and we've been calling for a couple of weeks, about pushing 2 weeks now. We're going to see a massive uptick for the next 60 days of coronal hole activity. Mark my words. How do I know this? I can't tell you. Anyway, there's a latest image. It's an hour and a half old. So here are our detected sunspot groups and flare probability. And you can see the flare probability quite high here, especially with these beta gamma class sunspots over here. That's 2866. And I think that'll be 2868, actually. So we've got 2363, 64, 65, 66, 67, and that'll be 68. So 2868 and 2866 are the most active sunspots. Those are both showing some signs of beta gamma class magnetic complexity. Planetary KP index at 1. Now we're back to Earth looking at global geomagnetism. No major upticks in that forecasted. Here's the GOES X-ray flux, and we can expect to see some spikes in this with the solar flare watch. We've also raised a coronal mass ejection watch, so you may not be aware of this. We did let the smAsho team know yesterday, but there is a coronal mass ejection watch also in effect. Stay tuned on the channel in case we switch that to a coronal mass ejection warning. But there is a watch in place. There are some massive filaments, especially in the southeastern portion of the sun. And we'll show you those later in the video. No spikes in the proton flux. No surprises to the channel there. So here is the real-time solar wind data. Pretty unremarkable over the past 24. Current conditions are, most current conditions are just under 9 protons per cubic centimeter for the solar wind density. Solar wind speed all the way down to 314 kilometers per second. Quite a slow solar wind. Density nominal. Next, looking at pressure here in the geospace. And the geospace magnetosphere movies page being highly uncooperative today. We can't show you the data. It's just not loading, and we have to get the video out. So here is the ground magnetic perturbation scenario. And we can expect to see fairly consistent geospace delta B here. Nothing too exciting expected to be going on. Some minor magnetic perturbations there over northern Canada. Nothing to write home about. Nothing too surprising happening here, ground magnetic perturbations-wise. Next, looking at a diagram of the solar system. If you're wondering where stuff is, it's one of the many things we cover daily on the Daily Space Weather. So make sure you're subscribed to the channel. Press like, press subscribe, tell your friends and foes about us. Congratulations on realizing we exist. We'll advance this 1 week. Here's where things will be in a week. New moon approaching in a couple of days. Next, a star chart. I use in-the-sky.org. We're not affiliated, but we would be more than happy to get the curators over there on one of our videos. We've also drawn on the ecliptic plane, which is the yellow line in the galactic plane. And the moon just rose. A crescent waning as we approach new moon. Our cosmology segment's going to be brief and integrated into the daily space weather today. Our random number generator picked something not random at all, Cygnus X3, one of the more important objects in space. It's one of the weirder things and one of the most likely cosmic ray point sources, one of the only known cosmic ray point sources. This object has a 4.83 hour periodicity. It's a high mass X-ray binary. It's got all kinds of features that you may not be aware of. It's an eclipsing binary, as it has a massive object orbiting a star about the size of Mars's orbit. Yeah, that's right. If Cygnus X3's blue supergiant companion star would be in our solar system, you'd be inside of it from the position you're currently in. Anyway, there's the 30-day chart of hard X-rays from Cygnus X3. Let's take a look at it in infrared. Actually, first X-ray. So here's a 9-year X-ray survey. You can see that extremely bright X-ray source there. That is Cygnus X3, the little friend that orbits a star the size of Mars in only 4.8 hours. Yeah, it's pretty serious. And it's a pretty weird object. It was weird enough for the ancients to orient Göbekli Tepe toward it. The tail of the swan, yes, Cygnus X3. It's also the brightest star in the constellation Cygnus Alpha Cygni, the tail of the swan. Let's take a look at it in infrared. We've got some funky data here. Now, this is located on the galactic plane, so it's in a very bright portion of the galaxy. Anyway, here is X3 on the 2 mass. We'll zoom in to show you this object, which has a jet oriented directly toward us. And the distance to this object is actually under debate. It's somewhere between 1,800 and 12,000 light years. And part of this star is actually right in your backyard, as again, it is one of the only known cosmic ray point sources in the entire universe. Cygnus X3. And if you want to read more about it, head to our forum at smAshomash.com/forum. You can find an entire thread about Cygnus X3 in the Cosmology Forum. It's entirely free. You don't even have to be logged in to see the threads. The astronomy picture of the day today is a flyby from the Galileo project. And it's the moon and Earth. You can check that out yourself at apod.nasa.gov. That's today's cosmology segment. We integrated it to the daily space weather. Check our playlists for additional cosmology segments. Next, looking at charging hazards. Yeah, the satellites that surround Earth, they may get charged by things like relativistic electrons for internal charging or low-energy electrons for surface charging. We don't see any charging hazards at the moment. Here's a 1-year chart of the relativistic portion of the electrons reported by Solon.info. Here's a 3-day chart as measured by the GOES 16 and 17. By the way, these electrons are measured at the F layer by a geosynchronous satellite using radiography. Nothing too exciting to report on there. Here's the forecast model. I think I was pretty much exactly on when I said we're going to see a little bit lower levels in the forecast. The yellow diamonds are the forecast. The yellow diamonds are the observation. The green boxes are the forecast. So next we're going to look at the total electron content forecast. Here's a diagram of the Earth's Van Allen belts. And this will give you ideas of where GPS error is most likely to occur, which is typically around the equator at noon. As when a geosynchronous satellite must communicate through a lot of electrons, it is prone to errors. Next, we're going to show you the F ionosphere layer located at about 300 kilometers of altitude. Here is the ionogram animation, courtesy of Australian Government Bureau Meteorology. We do see some low-frequency anomalies in the southern hemisphere. Nothing very major. And we'll bring up the latest image and show you the anomalygram. So there's the ionosphere in frequency. And here is the anomaly. So this is showing you the departure from the 30-day median in megahertz. You can see some high frequency and some low frequency anomalies here north of the equator. and some pretty significant high-frequency anomalies here west of South America. Anyway, there's the latest image. That's 10 o'clock Universal Time. Things looking fairly normal at the moment. Why do I always say Smash News Network, least busted name in news? Well, because we don't have an agenda. I'm not a fan of anything except for the truth. And so that is why I say least busted name in news. Here come bonus features in the form of the El Teide Ground-Based Solar Observatory. So here's the latest from the El Teide, Spain Ground-Based Solar Observatory. Looks like we've got some cloudy conditions over Spain once again here. But in any case, you can see a lot of filaments. You can see filaments up here, filaments over here. There is one down here also, I think. Not showing up well on this, probably because of just contrast effects. Let's continue on. Here is the latest intensitygram and the latest solar magnetogram. We've pressed refresh so you'll see it happen. So here are our sunspot groups, and we've got no less than 4 of them. That's a beta class sunspot. That is a beta gamma class sunspot. That is a beta gamma class sunspot. In the north, we've only got 1 group up there. That is at least beta class, so again, likelihood of significant solar flares much higher, especially as a result of these 2. Here are the fields in the north. And that is capable of producing some solar flares as well. Let's look at some more imagery here to close out the video. Now this one is 1700 and 171 angstroms. Some great imagery there from the Solar Dynamics Observatory. And here's some more wavelengths. This is 335 and 193 angstroms. There was a little burst here and a little bit of transverse waves coming out. If you look right around here, you'll see some transverse waves coming out of this sunspot right there. And sometimes you only see features in certain wavelengths. That's part of the reason why we show all the different composite views. We don't show every composite, as we have to decide what to show and what not to show every day. It's actually quite difficult to decide which portions of the sun to show. And we're going to close things out today in 171 angstroms. So thanks again for tuning in, everybody. Once again, congratulations on realizing our channel exists. Please share on social media, no matter how unfriendly the oligarchs that attempt to control your lives are about you being able to actually see your own posts, etc. Good luck with that, and may that solar wind be at your back.